In section 4, chapter 10, you're going to learn how to solve radical equations. Now let's make sure we understand just the title. A radical means that it's going to have a square root in it, and an equation means it's going to have an equal sign. Let's scroll down to the bottom and talk about the main goal of today. The main goal is to isolate the radical, okay? So you want your radical to be on either the left or the right by itself. Let's look at problem 1 and circle what we want to isolate. Do you see this radical? That is what we want to isolate. So we take away 7 from both sides, and we rewrite the square root of x equals 16 minus 7 is 9. Now, you see how x is trapped inside? In order to untrap it, we need to square both sides. So I squared both sides, and that gives me x, and this gives me 81. Something you should do with these problems is take your answer and check it. So you see where x is, we're going to replace it with 81. So we'll do the square root of 81 plus 7, and we're going to see if that makes 16. Well, that is 9 plus 7 because of the square root of 81. 16 equals 16? Absolutely. Let's try another problem. What is the solution to this equation? Alright, I'm going to circle my square root, which means I have to add 5 to both sides. These are very much a level 1 problem if I was giving them categories. So we get the square root of x equals a positive 3. Now what we do is we need to square the whole thing. I like to kind of put parentheses around all the sides, alright? So I get the square root, like if you square square root, you just get that thing itself, and that equals 9. Take it and plug it back in to do your check. The square root of 9 minus 5, and we need to see if that equals negative 2. Well, the square root of 9 is 3. Minus 5 is negative 2. This does plug back in, and it is the solution. Problem 2. The time in seconds that it takes for a pendulum of a clock to complete a full swing. And if you guys are having trouble picturing this, you know those clocks that go back and forth as they tick through? Okay, that's what they're talking about, that kind of a clock. Is approximated by this equation. T, which is time, equals 2 times the square root of the length of the pendulum over 3.3. If the pendulum of a clock completes a full swing in 3 seconds, what is the length of the pendulum, excuse me. So as it moves along, it takes 1, 2, 3 seconds to go across. Ready? 1, 2, 3, and then it's made it all the way across. So we write 3 equals 2 times the square root of L over 3.3. Now, for all things considered, I'm going to say that the square root is isolated. I know there is a 2 here, but watch what happens when we simply square both sides. I get 9 equals 2 squared becomes 4, and the stuff inside, L and 3.3, gets to come on the outside. The next thing I'm going to do is divide both sides by 4. Okay, so I'll move up here. That's 9 over 4 equals L over 3.3. The last thing I need to do is multiply both sides by 3.3 to clear it out. And I'm going to plug it into my calculator and get a nice answer to see if it is correct. Alright, so I get 3.3 times 9 over 4. Oh, sorry. 3.3 times 9 over 4, I get 7.25. And that, 7.425. That is how long the pendulum is. So we're going to say the pendulum is 7.425, and what is this in? Feet. If you read the problem, it says it's in feet. So that means you have a really, really big clock, and it's 7.4. The pendulum is 7.4 feet long, and that makes sense because it takes so long for the pendulum to swing all the way back and forth. If you want to take this number and plug it back in, I'm going to show you how it works. So you see my equation, I have the calculator next to it. If I were to do 2 times the square root of, the answer I got divided by 3.3. See how the answer becomes 3? That's because it should take 3 seconds. Let's try it one more time with the new problem. We have the same equation. The equation does not change. But this time they're saying it only takes 1 second. Now, because it only takes 1 second, that should imply to you, okay, that should imply that it should be shorter than before. It should be shorter than that because it only takes 1 second. Alright, so we do 1 equals 2 square roots of L over 3.3. See how we've isolated it? We square both sides, and we get, I'm going to move over to the right, we get 1 squared is 1 equals 2 squared is 4, and the stuff in the inside is now, it's not trapped anymore, it's just L over 3.3. Divide both sides by 4, and to clear your fraction on the right, you're going to multiply by 3.3. So times 3.3 times 3.3. Yes, I would allow you to use a decimal for 1/4 because it is a terminating decimal. So in my calculator, I'm typing in 3.3 times 1/4, and I get 0.825. And that is in feet for the length of the pendulum. Look how much shorter it is than the one above it. So this one up here is 7 feet, over almost 7.5 feet. It took 3 seconds. Down here, it's 0.83 feet approximate, and it only takes 1 second. Let's move on and talk about what to do if there are 2 radicals and all the terms are inside. Okay? And that's going to be problem 3 and the got it number 3. Now, what you need to make sure is put a little note here. 1 radical on left and on right. Can you see that? You want to make sure you have 1 radical on the left and 1 radical on the right, and then all you have to do is square it. So this side squared is just 5t minus 11. It like frees it from the radical. It's the opposite. This side is t plus 5. From both sides, I'm going to take away t. I get 4t minus 11 equals 5, and this is something you guys should be able to do, just solving for a variable. Add 11, 4t equals 16. Divide by 4, t is 4. Now what we need to do is make sure that this actually is a real answer. It is not what we call extraneous. So we're going to plug it back in. Okay, so here's where I'll do the check. I like it when you can do a check because you know if you did it right or wrong. So we do 5 times 4 minus 11, the square root of it, equals the square root of, plug in 4, 4 plus 5. 5 times 4 is 20. 20 minus 11 is 9. 4 plus 5 is 9. Well, the square root of 9 equals the square root of 9? Absolutely. They both equal 3. Move down to the got it. See how there's a radical on the left and a radical on the right? You just square both sides. So we get 7x minus 4 equals 5x plus 10. Take away 5x from both sides to start solving. You get 2x minus 4 equals 10. Add 4, 2x equals 14. Divide by 2, x is 7. Let's check our answer. Okay, plug 7 in. So you get the square root of 7 times 7 minus 4. And we need to see if that equals the square root of 5 times 7 plus 10. So 7 times 7 is 49, minus 4 is 45. Let's check the other side. The square root of 5 times 7 is 35, plus 10 is 45. These are both equal, so I know I did it correctly. Problem 4, finding what we call extraneous solutions. Extraneous means you get it as an answer, so we'll say you get the answer, but it doesn't plug in. Let's say it doesn't check. Okay? Let's try. Notice how the radical is isolated. You see how it's kind of just by itself, other than the question mark, it's by itself? That means we're ready to square both sides. N squared is, well, n squared. The other side frees it from its square root. So we get n squared equals n plus 12. Now I want you to write a star here. Anytime you see a squared variable, what do you set it equal to? 0. So you see all this stuff? I got to move it over. You guys did this in chapter 9. Alright, if you need to look it back over, you did this in chapter 9. N squared minus n minus 12 equals 0. Factor it out because that's how you learned. You get n minus 4, n plus 3. You would set each one of these equal to 0. N minus 4 equals 0, n plus 3 equals 0. And you get two answers. N equals 4, n equals negative 3. Now what we need to do is check them both in. Okay, you ready? So let's take our original equation and let's try 4 first. We have two checks. Keep it nice and small. Let's check 4. I'm going to write that down so you know what I'm doing. Check 4. So I just do 4. Does 4 equal the square root of 4 plus 12? That's like asking, does 4 equal the square root of 16? The answer? Yes, it does. 4 is the square root of 16. Now we need to check negative 3. So we're going to do, does negative 3 equal the square root of negative 3 plus 12? That's like asking, does negative 3 equal the square root of 9? No. The square root of 9, okay, see how it's a positive there? The square root of 9 is a positive 3. This does not work. Our answer is only 4, not negative 3. I'm going to finish the rest on this video. Try this again. We're going to square both sides. What is a negative squared? A positive. So I get positive y squared equals y plus 6. Again, the right side gets freed from its radical. Set everything equal to 0 by taking the y and the 6 over, both becoming negative. Factor. Try pausing the video and factoring, because you should be able to do it without watching me. You should get a minus 3 and a plus 2. Set those both equal to 0, just like you learned in chapter 9. You get y equals 3 and y equals negative 2. Now we're going to check both of these answers. Here we go. Let's check the positive 3 first. So I'm going to ask, and I see how it says negative y? I got to plug it in, so I'm going to plug in a positive 3, which actually ends up being a negative 3 because of this negative sign. Does negative 3 equal the square root of 3 plus 6? That's like asking, does negative 3 equal the square root of 9? No, it does not, because the square root of 9 is a positive 3. Now let's check negative 2. By the way, sometimes both of them aren't answers, so you need to check both. Don't assume anything. A negative 2 is a positive 2. We need to see if that equals the square root of negative 2 plus 6. So does 2 equal the square root of 4? Yes, it does. Negative 2 is my answer. 3 is extraneous. Now sometimes students will assume that the positive is the answer. Please make sure you never assume anything. You want to make sure you actually check it back in. Let's go to problem number 5. Isolate this radical just like you did in problem 1. The square root of 3y equals, take away 8, negative 6. Square both sides, and you get 3y gets freed over here, and you get a positive 36 because a negative times a negative is a positive. Divide by 3. Y is 12. Now you're going to take this 12 and you're going to check it. So we do the square root of 3 times 12 plus 8. And we need to see, is it 2? Well, that's the square root of 36 plus 8. And we need to see if it equals 2. Well, that's 6 plus 8. And 6 plus 8 does not equal 2. So the answer is not 12. This is a no solution. There's no possible number that you can put in there. Let's take a look at the got it. What is the solution of the following? 6 minus the square root of 2x equals 10. I'm going to take away 6, and I'm going to get the negative square root of 2x equals 4. At this point in time, you can either divide the negative over, or you can just square it as it is. I am going to square it as it is, and I'm going to get a positive, because a negative times a negative is a positive, 2x, it has been freed, equals 16. X equals 8 when you divide. Check it out. Does 6 minus the square root of 2 times 8 equal 10? That's saying does 6 minus the square root of 16 equal 10? Well, that's like saying does 6 minus 4 equal 10? No, 6 minus 4 does not equal 10. 6 plus 4 does. So there is no solution on this problem. If you have any questions, you can open your book and you can go ahead and do the lesson check. Ask me anything that you need to from the lesson check. If you feel confident about the lesson check, then you're able to do the majority and all of section 10.4.